In the previous video, we are just about to create our books table in DynamoDB. But before we proceed, DynamoDB is asking for two key pieces of information, the partition key and the sort key, which is an optional. They are critical to how DynamoDB structures and retrieves your data. So it's important to fully understand their power and purpose before moving forward. Let's dive in and understand the power of partition key and sort key. Let's start with partition key. So what exactly is partition key? Imagine you have a database and as your traffic grows, the volume of data and requests becomes massive. Naturally, the larger your data, the longer your queries take. It puts a lot of pressure on your database server and leads to slower response times. That's where DynamoDB steps in with a clever solution called partitioning. Your data is divided into partitions. Whenever you insert or query data, the partition router uses a function f of x. This function is defined by DynamoDB. In a single table, there are multiple attributes. You need to select one of these attributes and partition router use that attribute as a key to determine in which partition a data should enter. And for an instance, I'm selecting ISBN as an attribute for partition router. Now, whenever we insert new data, first it hits the partition router and partition router pulls the ISBN from the data and put it in a function f of x. And this f of x will decide in which partition this data should go into. So ultimately, ISBN is deciding in which partition the data should enter into. So we call this attribute as a partition key. Now let us quickly see what is happening inside the partition router. Let's assume we have two partitions with ISBN as the partition key. This is purely hypothetical as managing the number of partitions and the partition routing is something you don't need to worry about. Since DynamoDB is a fully managed service, it automatically handles all partitioning behind the scenes. Your focus remains on writing your application code while DynamoDB takes care of all the complex operations in the background. Since this process is essentially a black box, I'm using these assumptions to better illustrate the concept with a simple example. So here we have elected ISBN as partition key, and partition router substitutes ISBN in its function f of x. Now let us make an assumption on the function f of x. Let f of x is equal to x modulo 2. X modulo 2 means it's the remainder when we divide the x by 2. Now as ISBN is the partition key, the partition router calculated f of x for each value in ISBN. Now here are the calculated values for f of x. And the result of this function f of x is determining to which partition this data should enter into. Let's say we are querying a book by its ISBN. The partition router calculates a function f of x to determine which partition holds the book. Instead of searching the entire database, it targets just the right partition, making retrieval fast and efficient. That's the power of partitioning and the role of partition key. Now you know what is partition key. Now let us talk about sort key. Imagine you have a group of people standing in a queue. Now you need to pick out the ones who are tall enough for a spot. Let's say with a height greater than 5.6 feet. If the people in the queue are not arranged in any specific order, you will have to check the height of each person individually, one by one, to find those who meet the height requirement. This is a time-consuming process because you are going through the entire queue. Now let's consider a situation where the people are already arranged by height, from shortest to tallest. In this case, once you find the person who meets the height requirement of 5.6 feet, you can easily select all the people from the point onward without having to check every single person. The task becomes much faster and more efficient because the queue is organized. The same idea applies to databases. Assume this is table of items and I am making the price attribute as a sort key. So once you set price as the sort key, whenever you insert new data, it is automatically arranged in order by price. This allows for much faster retrieval of specific price values or performing range queries efficiently. Now I hope you have understood the power of partition key and sort key. In DynamoDB, when you are creating a table, the partition key is mandatory while the sort key is optional. This gives you two options for creating a table. You can create a table just with the partition key, which acts like a simple key. Or you can create a table with both partition key and a sort key, forming a composite key. Regardless of whether you are using a simple key or composite key, it must be unique in DynamoDB. This is why we refer it as a primary key. When you are using the partition key, it's called simple primary key. When you use both partition key and sort key, the combination is called composite primary key. This ensures that each item in the table has a unique identifier, maintaining the integrity of data. Now this is the summary of what we have learned so far. The primary key is a unique attribute required when creating a DynamoDB table. It determines where the data is stored and acts as a primary identifier for each item. Each partition key value must be unique in a simple primary key setup. When it comes to the sort key, it is an optional attribute. When used with the partition key, it forms a composite primary key, allowing multiple items with each partition key but unique sort keys. It helps organize data and allows for efficient range queries. As we create our first table in DynamoDB, let's start with a simple primary key, which is just the partition key. In future projects, we will introduce a sort key once we have established a solid foundation using the simple primary key. This will help us gradually build up to more complex data structures. Now, this is the table we will be building in DynamoDB, and we need to determine the partition key based on our use case. For example, if we frequently query by ISBN, we would set ISBN as the partition key. Alternatively, if we often query by price or other attribute, we use that as a partition key. In case of simple primary key, it's important to ensure that the partition key is unique for each item in the table. In this table, I am planning to query the items in the table by ISBN, and also it will be unique across the items. So I am electing ISBN as the partition key. Now let's continue from where we had left before. Let us enter the partition key which we have decided. So here ISBN becomes my partition key, and in the upcoming projects we will use the sort key as well. For now, let us leave it as a blank as it is optional. And we will also discuss all these advanced concepts later. For now, let's go ahead and create a table. Now let's wait while it is spinning up the servers, creating partitions and creating a table for us. Now the table was created successfully. And in the upcoming session, we will be discussing about how do we insert the data, how do we retrieve the data, and how do we update the data in database. See you in upcoming session. Thank you.